All right, so dig them out, dig them out. That's talking about your notes. Okay, traveling down.
Schools you say anything.
Okay, here we go. Today, your job is one job. Sorry, two jobs. But the second job is so easy. Here's the job you have to do. You have to find something today. What do you have to find? You gotta find the inverse. You gotta find the inverse of a given relation. And I'm gonna do this. I'm gonna tell you, I'll give you a function today, and I want you to find the inverse of the function. And once you find the inverse, tell me if the inverse is a what? Is the inverse a function? Well, here's how you're going to tell me. It's going to be a graph, guys. You're going to graph the inverse. Do you remember this? If this is the inverse, if it's just a line like this, is this a function?
Yes.
How do you know?
Wait.
Because you put it in twice.
You get answers.
What's that called?
The vertical line.
Vertical line test. Yeah, the vertical line test says if you hit it, what? Once, it's a function. So that's how easy this part is. This is such an easy part. So when would it not be a function? How about a parabola going this way? Is that a function? No. Once, twice, we hit it twice, it's not a function. So this last part is so easy for you guys. The hardest part for you is just finding the inverse of a what? Given function. I'm going to give you the function, find the inverse, okay? Now, let me just do it for you really quick. I'll show you what a function looks like and its inverse, and then you'll kind of get it right away, I hope. Okay, so here's the function, f of x, that's the function. This is called the inverse function, and it's denoted how? F of x. But if it's the inverse, we put the exponent -1 up above. So the function is f of x, and the inverse function is f of x raised to the what? -1. Okay, here, let me show you a function. This is a simple function. Y equals x plus 5. Okay? First of all, do you know what it is? If I graph it? Yeah. X to the first. What is it? It's what? It's linear. It's a line. That's all you have to say. It's a line. Okay, so here's the deal. If you were going to graph it and you made a table, you don't really have to make a table because this is the y-intercept, this is the slope, I get it. But if you did make a table and you started putting numbers in like 0, what's the answer? 1, 2, 7. Okay, so 0, 5, 1, 6, 2, 7 are the answers. Well, the inverse function is still going to be y equals. Now think about it. Inverse. It's like what undoes addition? So what do you think the inverse function is? X minus 5, yeah. So let's see if it works, okay? So here's how you know if it works. Okay? See these points back here? 0, 5. See this y? Put it there, and now put it here. What's the answer? 0. So in a function, if you put in 0 and you get out 5, in the inverse, what? The y value becomes your x value. Yeah, the x and y get what? Swapped over or flipped. Okay, so basically they just get switched. So this should work, right? 1, 6 should become what? 6, 1. 2, 7 should become what? 7, 2. Does it work? You put that in, does it work? Yeah, this is the inverse function. Your job today is this. I'm going to give you this, and guess what you have to find? You got to find that. It's not hard, okay? But I'm just trying to say that's your job today. Okay, now go back here, right here. And now we're going to look at these two tables, and we're going to call this one not relation T. By the way, relation just means a bunch of ordered pairs. I'm going to call it function T. And I'm going to call this one inverse of function t. Okay? And now what they're doing is they're telling you function t is this table, where inverse function t is this table, and they're leaving a bunch of blanks for you. Well, now that I already showed you, you should know the blanks, right? 0, -5, -5, 0. 1, -4. -4, 1. That's what I'm trying to get across to you. Just switch the x's and y's, and you've got the inverse. 2, -3. -3, oh, sorry. -3, 2. Next, 3, -3, -3, +3. So a function and its inverse, all the x's and y's all get what?
Swapped.
Yep, that's it. Now down here it says graph this table here, graph this table here. I don't want you to do that. I want you to do this. Kind of cross this one out. What I want you to do is actually graph it here, both of them. So if I look at this table, this is function t. Colton, you don't have notes?
I don't know where they went.
Huh?
I don't know where they went.
Oh. Okay, I gotta say something. Guys, you can't sit there without notes. You've got to work with me. You don't work, you don't learn much. Okay, here we go. Graph it. What was it up there? I can't remember.
0, -5.
Okay, right here. And
1, -4.
and
2, -3.
okay, and
3,
-3. Okay, right here. These 4 points are known as function what? T. I'll just say ft. Okay. Next, graph the inverse function on here too. That would be 0, -5, right? Is it -4, 1?
Yeah.
-3, 2, and -3, 3, correct? Okay, so this would be known as the inverse function, denoted f of x to the -1. Oh, I guess I should probably put a t there, because they called it t. Okay, all right. Here's the function, here's the inverse function, and that's it. That's your job today, graph, graph, graph. Now, what I want you to do is this. This is nothing that the book talks about. I'm just trying to get a few of you ready to go to pre-calc next year. Pre-calc, we talk about inverses, but I want you to look at the graph. Okay, look at this point, 0, -5, look at this point, -5, 0. Look at these points.
They're symmetrical.
They're what?
They're symmetrical. There's a line.
They're
that's
symmetrical over what?
over the diagonal.
1.
What?
Y equals 1. Like,
Ooh, we were so close.
Y
x
equals x.
No, I think I heard it.
Y equals x.
Y equals 1x. Okay, guys, remember y equals x would look like this. That's slope-intercept form, right? So you say y-intercept 0, slope is what?
1.
Up 1 over 1, up 1 over 1. So basically the diagonal, somebody said diagonal. Okay, there.
It's a diagonal.
Okay, so y equals x is the reflection line. If you look at every one of these points, wouldn't this distance from there to there be the same? From there to there? They're equal distance apart, right? So whenever you look at a graph, you go, well, yeah, this graph looks like it's a reflection over y equals x. If so, they are inverses of each other. So then you know you did it right, is what I'm trying to say. Okay? Does that make sense? Some sense? We talk about this in pre-calc next year. That's just a little insight for next year. But this is a good clue for you. Is my inverse right? Or doesn't this kind of almost look like this? I mean, reflection, in a way. All right, well, if you don't quite get that part, it's okay. It's not going to be asked on the assignment. Your job today is to do this. What is the what? Inverse. Find the inverse of this. This is your function they give to you. F of x equals 2x plus 8. Here's how I would start, guys. I'd go like this. I just copy it down, I'd replace that y with f of x. And they want me to find what they call the what? What do they call it? The inverse. So they want you to go find this thing. Okay? Go find the inverse. Well, to find the inverse function, you got to know a little bit about inverses. What about the ordered pairs x and y? What are they again? xy in the function is what over here on the inverse? Yeah, it's just switched around, isn't it? So guys, what you can do right now is take your x value and replace it with y. Just switch the x and the y. This is x, now it's y. F of x was y, now it's what? Now it's x. That's how you start these problems. So if you want to write a note to yourself, the first thing I will do when I do today's assignment is switch what? X and y. Period. That's the first thing I do. And now you want the inverse function. Well, when you want a function, all functions are solved for y. This is not solved for y, so the second thing you'll do is what? Solve this equation for what? Y. So now your job is to look at this and solve it for y. Yes, sir. Tim.
Instead of doing that, could you just graph your first one?
But it says what is the...
Yeah, but graph that first and then do the opposite of it.
You don't, when you say opposite, you mean switch all the...
Yeah, could you just do that instead of solving it first?
You could, I suppose you could. But really, the most important thing to me is, can you find the inverse function? The graphing is pretty simple. You know, you can do what you said, that's fine. But when I say find the inverse, you gotta know how to find the inverse. Okay, so how do you solve for y, guys? How do you get y all by itself?
Subtract 8.
Subtract 8. Somebody said divide by 2. Well, you can. Divide by 2, divide by 2, divide by 2. You can do that, but that's typically the last thing you do is divide by 2. Most people will say minus 8, minus 8. So x minus 8 equals 2y. And now the last thing you'll do is what? Divide by 2 and get what? Divide by 2, divide by 2. Now, do you guys remember that I said when you see three numbers, 1, 8, and 2, if all three of them have something in common, go ahead and reduce it. But if not, 1 and 2 have nothing in common. Typically, I would leave this problem alone. I just leave it like that. Okay? But some students don't like that. They like to change things over. And they'll change this to x over 2 minus 4. Minus what? 4. Some students will say y equals this. And that's fine. You want to write that? That's fine. Okay, the last thing, you're done by the way. The last thing I'd like you to do is put this in function notation. Since this is called the inverse, I'd like you to replace this y with function notation. Since it's the inverse, we're going to write f of x raised to the negative 1 equals this. So when it says find the inverse, I did. I found the inverse. Okay? So there's the function, there's the inverse, and now the question is this a function? Well, let's just quick graph both of them. If you graph both of them, all right, this one, just make a quick table, and then after you make the table, switch x and y to get that table. Give me something to plug in.
0.
Okay, that was the easiest number you can choose. 8. Okay, next.
1.
Another easy one. What do you get? Okay, now what? 5.
2.
If you do 5, 2 times 5 is 10. 10 plus 8 is 18. You fell off your graph. 2. Okay. 2. 2 times 2 is 4. 4 plus 8, 12. You're still off your graph paper. Yeah, you might want to quit getting bigger. Now you might want to get smaller.
Count by 2.
How about -2? If you did -2, what would you get? -4 plus 8, you get positive.
Or
Okay,
you just count your y-axis by 2.
you can change your scale. You can do a lot of different things. But all I'm saying is, I don't want to get too far off my graph paper if I can help it.
So there's more
You
than
just
one
need
right
4
way to do
points.
this.
No, you can. Okay, first of all, here's what I know. I know this is linear. This is just a line. It's a line. I only need 2 or 3 points. 2 points would have been good enough. I typically do 3 for lines. So 0.8 is here. 110 is here. -2.4 is here. Here's your function right here, guys. That's your function. Okay, that's f of x. Okay. Now do the inverse function. Oh, well, do I really have to make up ordered pairs? Probably not. Since the inverse function, you just switch x's and y's, I could make a table quick. What's the table going to be? 0.8, 8.0. 110, 10.1. -2.4, 4, -2. There. I didn't even have to think about it. I just switched them. Okay, 8.0, about right here. 10.1, here. 4, -2, here. There it is. There it is. And just looking at this, again, for me, I want to know that, did I do this thing right? Well, is it really a reflection over this line?
Yes.
I mean, does this distance here look about, whoa, I'm way off. That distance and that distance look about the same?
Indeed.
Yeah, they do. And that's an eyeball thing. That's like, you're just eyeballing this thing thinking it's perfect. But there isn't much to do once you make that first table. Just switch x and y, graph it. Oh, last thing to do, sorry. It does say, is the inverse a function? Look at the blue one. Is the blue one a function?
Yeah.
Vertical line hits at what? Once. Yes. Is the inverse a function? Yes. Okay? Good? Oh, I suppose I should do this. Label this function f of x to the -1, because that's the inverse function. Because I won't know which is which. I want you to tell me, this is the function, this is the inverse function.
There's already.
Yeah. The yellow line does not need to be there. I'm just doing that just to show you the reflection line. This is just me drawing the reflection line. Okay? That's it. We got 2 more to do. They get a little harder. That's why I got to do 2 more of them. Okay? There we go. Next. Do it again. It says, what is the inverse of that? Well, again, that is your function f of x equals 2x squared. Right? So what's the first thing?
Switch x.
Switch x and y. Well, where's the y? I don't see a y. It's f of x. F of x is y. So when you switch it, you'll put x. When you switch the x, you'll get 2y squared, right? So this is us looking for the what? We're looking for the inverse. Solve it for y. What do you want me to do?
Divide by 2.
Yeah, you guys, you want to get y squared all by itself, because if you get y squared by itself, you just take the square root of both sides. So divide by 2 first, and you knock out the 2, and now it says x over 2 equals y squared. And then you're going to what now? Take the square root, both sides, right? And you get y equals,
Square root of x over 2. simplify it?
Oh, you want me to simplify? I could simplify, but I'm not going to. I'm just going to say something. You're missing something.
Can't have a radical.
No, you can't have a radical, but here's the deal. I can put a number in, divide by 2, and then take the square root of it and get approximately the point. What you guys are missing is, and every class did this. Do you remember this? That's been on your test before. What'd you say the answer was? Yeah, when you guys take the square root of both sides, you have to bring in the plus or minus. You have to. So guys, you're missing something here. You're missing your plus or minus. So you should put plus or minus. That will get you all the points on your inverse. And then right about here, guys, you should rewrite this as f of x to the negative 1. There. That's your inverse. So you have your function here, you have your inverse function there, you're practically done. Because really to get the points, it's pretty simple to get points. Make a quick table. But you're going to have to think a little harder at this one.
Put in 1.
Okay.
0.
Okay, tell me what, just before you start saying that, just tell me what the graph looks like. Is that a line? Is this a line?
No, round.
It's parabola. How do you know?
Squared.
It's quadratic. It's squared. It's a parabola. What's the most important thing on a parabola? Vertex. Put points in until you find the vertex. Ready? You said what, Adrian? 1?
You put in 0 too.
Okay, I'll put in 0. Now, okay, put in a 1. 1 times 1 times 2.
2.
2. Now put in 0, he says. 0 times 0 times 2.
0.
Okay. Well, so far I have this. 0, 0, 1, 2. That doesn't help me because that looks like a line. I need more points.
Negative 1.
Negative 1, okay. Negative 1 goes in. Negative 1 times 2. 2. Here. I think we see something like that, which means I think I already have the vertex. It's 0, 0, right? Okay, I have a little piece of the parabola. Let's get one more point. Throw something.
2.
2. Try a 2. 2 times 2 times 2. 8. So 2 gets 8, which pretty much means I could mirror that over and get negative 2, 8, right, guys? Okay, like that. So I could do another one just like that. Okay, so that is my function right there. Now here's my inverse function down here. So really, all I'd have to do to make a quick table is what? Switch 1, 2, 2, 1. 0, 0 doesn't change. 2, negative 1, 8, 2, and 8, negative 2. There you go. And once you switch them, then you just quick graph them, and you got it. 0, 0 is right here. 2, 1, 2, negative 1. Here, here. What's it look like right now? It's a parabola going which way? Sideways. It's this way. So it's the same graph. It's just turned sideways. Okay. 8, 2 is here, and 8, negative 2 is here. There, there. This is the function f of x. This is the inverse function f of x to the negative 1. Good? Question, is the inverse? It says up there, is the inverse a function, yes or no?
No.
No.
No, because
Line method.
vertical line touches it twice every time. Good? All right, do the last one. Guys, you should be pretty good at this by now because it's not hard stuff we're doing. It's just, can I find the inverse? Got you started a little bit. Switch x and y, solve for y now. That's what you're doing, right? Solving for y. Second thing is solve for y. And maybe you're stuck right now. Maybe you don't know what to do. How do you solve for y? What do you get rid of first? The minus 3 or the square on the outside?
Square root.
You got to get rid of the square so that you can get it down to just y minus 3. How do you get rid of the square? Take the square root of this side. Take the square root of this side. The square root will knock out the square. All you have is y minus 3. Equals what?
Square root.
Plus or minus the square root of x.
Thank you. Had a feeling we're going to forget that. Plus or minus. Yeah, it's plus or minus the square root of x. Okay. One more thing. Just do what?
Add 3.
Add 3. Add 3 to both sides. If you add 3 to both sides, you get y equals. And when you add 3, you can put it in front or you can put it in the back. I choose to put it where? No, I like to put it in the front. I do. Because if I put it in the back, sometimes it's confusing. Is it inside the radical or is it outside the radical? I can't tell sometimes. So this is pretty clean cut. When you told me to add 3, I did. It's 3 in front plus or minus square root of x. This is called the what? This is the function. This is the inverse function. So now maybe just give me a little bit of function notation. If this is the inverse, I'll just call it the inverse of f of x. And then, of course, it's 3 plus or minus square root of x. There it is. Okay? Let's go make a table. Let's graph the first function and then the inverse. There's the function f of x. What do you think it is? You think it's a parabola? How come?
Quadratic, because it's quadratic as a square.
It's got a square, it's x minus 3 times x minus 3. You know if you FOIL it, you'll get yourself an x squared. It's parabola. Yes, ma'am? Yeah. Well, I think you... Okay, so anyways, guys, x minus 3 squared is a parabola. Now, do you guys recognize that parabola from last September? I know that's a long time ago, but do you recognize it? What do you think?
You go to
Where?
you go to right 3.
He says, Isaac says, go right 3. Is he right?
Yeah.
Guys, do you remember this is a translation? When it's inside parentheses, it's always going to be, take the parent and go where? Left or right. But when it's inside, it's the opposite of what you think. Minus 3 seems this way, backward. It's not. It's which way?
Just
Forward. This is just forward 3. So to me, that helps me. Because now I kind of know the vertex. The parent is always 0, 0. If I go right 3, guess what the vertex is?
3, 0.
Yeah, it has to be 3, 0. But let's just check it out. Put a 3 in. Ready? 3, take away 3 is 0. 0 squared is 0, 0. Okay, so we're hoping that's the vertex, right? Okay. Well, what would be another good number? 4 or 2. Okay, put a 4 in. What's 4 minus 3? 1. 1 squared. 1. Put the 2 in. 2 minus 3, negative 1. Negative 1 squared. 1. Looks like Isaac, kind of looks like Isaac was right. He said right 3. He was right. Okay, give me just one more point. 5. Okay, try 5. 5 minus 3. 2. 2 squared. 4. 5, 4 is here. And you should know you can mirror it over the axis of symmetry, so this one would be here. There you go. That is the function, f of x. Where's the inverse? Well, the inverse, just make a quick table of it. X, Y. Switch your numbers. Instead of 3, 0, go what?
0, 3.
Okay. Help me on the other ones. I can't see them.
1, 2,
Be 1, 2,
1,
1,
4.
4,
4, 5.
4, 5. Okay. And I think there's another point I graphed, but we can leave that one alone. So where's 0, 3? It's right here. 1, 2. 1, 4. See it? 4, 5. About here. So when your function's a parabola, your inverse function is also a parabola, except it goes which way? Sideways. So I could mirror this point down here and go about here. There it goes. Yes or no? Is the inverse a function? No. Vertical line hits it twice. So the answer is no. The inverse is not a function. Okay, so you will have to graph functions and inverse functions, and then you will have to be able to tell me, is the inverse function a function? Yes or no? Vertical line test will tell you yes, it'll tell you no. Question? I have graph paper right there. I'm going to tell you guys this. This is getting weak and weak and weaker. Okay, and this is about my whole day, 4th period, 5th period, and 6th. There's only about 15 to 20 papers here. I have 60 students. So these students that don't want to do their work are getting zeros. And it's not very easy just to pass a test when you don't do much homework. So guys, you're going to have to turn your motivation switch back on and get going. This, summer will come. Life gets better, but for now, you just got to put a little more hard work in this, okay? Some of you are just dropping the ball. Okay? It's got to start doing your work. Yes, sir. Huh?
Yes.
Did I not record this lesson? Oh.
I don't know.
Well, I thought it was.